Okay, I hear the recording in progress, so we'll share screen. Okay, so we're already up to 11.11, our last section. I'll do some more problems today. I can really take my time on this. And that means next week, I'll probably spend some of the time doing some review questions. If you have review questions, feel free to bring them up. Okay, but as soon as I finish 11.11, which might be tomorrow or Monday, then I'll start doing review questions. Okay, our last regular test is Thursday the 9th, usual rules for exams. So you submit all of this homework, at least 70% required. Okay. And you can have one cheat sheet, one formula sheet on the exam, but nothing else. So Friday will just be an office hour. You can join or not join. And then you will just study for the final exam. Okay, so final exam is on Friday the 17th. I do have a suggestion. Suggestion is to study one exam a day. So maybe Friday the 10th, go back and review the first test. Then the week after, Monday, Tuesday, Wednesday, Thursday, exam 2, 3, and 4, and 5. And that'll lead us to the final exam. Okay. So I would suggest going back to the old videos. And you know the video was the day after the exam. So just scroll back down to your previous exams, right? It's usually the day after. So the first exam you can find on Saturday, September the 4th, right? Second exam would be Saturday, the 25th of September, and so on. And then the last exam you'll get on Friday. Again, I may not give you back your very individual exam, but you should be able to have the solutions video on Friday available. Okay. Right. So again, my suggestion is go back and review one test a day. So Friday the 10th, review the first test. Then Monday, Tuesday, Wednesday, Thursday, one test a day, test 2, test 3, test 4, test 5, and then final exam. Okay. Questions I pick will be questions that are very similar to previous exams. Okay. And again, I have office hours during finals week, the 14th, 15th, and 16th, Tuesday, Wednesday, Thursday, 8 to 10 a.m. Use the same Zoom link for those office hours if you think you need it. And the final exam, same Zoom link all the way through. We don't have to change our Zoom link for the final exam. You get 2.5 hours for the final. Okay. All right, and you'll get your last quiz tomorrow also. All right, so that is that. And let me go get started with some of the problems today. Let me check the chat. How many questions are on the final? Okay, so let's see. I tend to give 10 questions on regular tests, so maybe 15, 20, something like that for the final exam. Okay, so let's say if I give 15 questions, I would pick 3 questions per test. And if I give 20 questions, that would be what, 4 questions per test. Okay, so I'll just go to each test. I'll just go to the first test and I'll just say, I like that one, that one, that one. Then I go to the second test, I like that one, and then I'll just put the questions on the test. It doesn't have to be the very same questions, although it might be, but I might just modify it a little bit. Okay. And so, you know, it should be representative. And think of it this way, I've never felt this way. I'm not out to get you. Okay, so I'm not out to intentionally, oh, I'm going to make the super hard final exam that nobody's going to pass. That's not the way I do things. I'll make it fair. Obviously, if you don't study and you don't do anything, it's not going to matter. But if you give a reasonable effort and been keeping up all semester, you should be okay in the final exam also. Okay. All right, any other questions, feel free to bring it up or put it in the chat. 11.11, let me show you the questions again. I don't remember if I showed it to you, but here they are. Okay. And I'm on page 780. And then that's it. Then we're done with Calc 2. Okay, those of you going to Calc 3, that's the next chapter. Okay. You're in space. Okay, so if you do Calc 3, you're going into 3-dimensional calculus. Okay, well, I take it back. Your teacher doesn't have to use the same book. Your Calc 3 teacher is allowed to pick a different book, depending on who you take for Calc 3. All right, so last time I did 3 star. Let me do 7. F of x is natural log of x, a equals 1. So these problems, they want you to find T3. Look down at problem 3 through 10 there. I can't point it out because I'm using 2 hands to hold the book up. But T3 of x means the third Taylor polynomial. It's a third degree, the best cubic approximation. We're doing the same thing as we did before, except not putting dot, dot, dot. So once you get to the third derivative exponent factorial, once you get to the x cubed, then you can stop. And this time, don't put the dot, dot, dot. So it's the best cubic approximation. Okay, notice this is a step up from what you did in Calc 1. In Calc 1, you were always giving the T1, the linear approximation, right? Remember, you did a lot of problems that said, find the equation of the tangent to the curve, blah, 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 at the point, whatever. And there was a line, the tangent line approximation. So the tangent line was the best approximation for the curve. If you're forced to have a linear, the approximation gets better if you can do a cubic, third degree. So we're coming up for problems 3 through 9 with the best cubic approximation, but you can go as high as you want, right? You can do the best 7th degree approximation. Back on 768. The best 7th degree approximation for the sine would be that. You want a better approximation, go farther. This is a good cubic approximation for e to the x. This is the best 6th degree approximation for cosine x. Just don't put the dot, 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 as it were. Okay. So ln x. So you find 3 derivatives, plug in 1. Okay, you're centered at a equals 1. That means even right now, if you're getting a lot of this mixed up, just put a sample problem on your formula sheet. Okay, right now, I already know it's going to be x minus 1 to the 0 over 0 factorial, x minus 1 to the 1 over 1 factorial, x minus 1 squared over 2 factorial, x minus 1 cubed over 3 factorial. And now you don't have to put the dot, dot, dot because they say stop at T3. The only difference between here and the previous is before you were doing plus dot, dot, dot. You go infinitely far, now we're not. So right here, even right here, the E and the F part, exponent factorial, is already predetermined. You just need the D part. Okay, so exponent's done, x minus 1 to 0, 1, 2, 3. Factorials are already set, 0 factorial, 1, 2, 3. And now the derivatives. So ln x, first derivative is 1 over x, or x to negative 1. Second derivative is negative x to negative 2, which is negative 1 over x squared. Third derivative is 2x to negative 3, or 2x cubed. Now we're centered at 1. I keep plugging in 1. ln 1 is 0. Plug in 1 here, I get 1. Plug in 1 here, negative 1. Plug in 1 here, 2. These go in front of the e's, exponents. So 0, 1, negative 1, 2. And just clean it up. This is gone. This is 1 divided by 1, which is 1. This is minus a half, plus 2 over 6 is 1/3. And there we go. And by the way, this does not violate a law of having 4 terms because the answer is just a third degree. The third degree happens not to have a constant, so it doesn't matter if there's no more terms, just do this. Okay, now if you're writing an infinite series, my rule is to write down at least 4 terms. Okay, but it says give T3, the third degree polynomial. This is the third degree polynomial. I cannot write any more, even though I'm just writing 3 terms. Okay. Excuse me. Okay, number 9. X e to negative 2x, center at a equals 0. Okay, this is one where we're going back to the Maclaurin series for e to the x. The same page we looked at. Keep going back to it. I can find it. Page 768. So e to the x, notice e to the x is not alternating, just x to the n over n factorial. And then we manipulate. Now, I could do this problem just like this one, but I don't feel like taking a whole bunch of derivatives of this. I'm guessing you don't either, right? I can find the first derivative, second derivative, third derivative, and so on. Not nice, very clumsy. Instead, I'll just start with e to the x and manipulate. Okay, so e to the x to the 0 over 0 factorial, plus x to the 1 over 1 factorial, plus x squared over 2 factorial, plus x cubed over 3 factorial. 4 terms, but we're going to have a cubic in a final answer anyway. And now, just like any other function, e to the negative 2x, right there, right there, right there, right there. Erase, parentheses, negative 2x. Erase, parentheses, negative 2x. Erase, parentheses, negative 2x. All the way through. Okay, I cleaned this up a little. That's still 1 minus 2x. Let's see, that's going to be 4x squared divided by 2, 2x squared. This is a minus 8x cubed over 3 factorial, which is 6. Negative 8 over 6 reduces negative 4/3. Now I just multiply both sides by x. So multiply x here. That becomes x minus 2x squared plus 2x cubed minus 4x to the 4th. Okay, so here is the power series expansion for x e to negative 2x. What is T3? I stop right here. I don't put this. T3 means third degree. So I only put these 3 down. So final answer T3 is x minus 2x squared plus 2x cubed. So this answers the question of what is the best cubic approximation to this function near a equals 0? This is the one. So we're sort of just like back in Calc 1 when you say give the equation of the tangent line to the curve the best linear approximation at a point. This is the best cubic approximation. You could say the same thing of what's the best quadratic, 4th degree, 5th degree, and whatever. Right now we're specifically looking at cubics. Why? Because the problem said so. Okay. And let me see, maybe. Why is the sign positive between 2x squared and 2x cubed? Okay. Well, maybe I made a mistake. X minus 2x squared. Okay, I think you're talking about this sign here. Okay, so that came from over here, I believe, right? So negative 2x squared is 4x squared. 4x squared divided by 2 is 2x squared, so I think that's okay. That's going to be positive, negative, positive, negative, right? So I think we're okay there. Plus, minus, and then multiplied by x. So I think we're okay. But because I'm plugging in negative 2x, that makes it alternating, right? So plus, minus, right? Okay, so I think we're good there. I believe that answers your question. If I didn't answer it, then ask me again or reword another way. Okay, so that takes care of most of those kind of problems. Okay, now for 13 through 21, this is new. So approximately f by a Taylor polynomial. Okay, that's the same as before, but now use Taylor's inequality to estimate the accuracy of the approximation, which lies in a given interval. So the new stuff is my variation on this, page 775. And I'll show you my version. Okay. So this is what I highly advise you to have on your formula sheet. So absolute value of R sub n of x, which means the remainder. So Rn is remainder if I stop after n terms. Okay, so remember, theoretically, I'm supposed to go infinitely far. Practically, you can't go infinitely far. You stop somewhere. The homework problems up to 9, they said stop at T3 or wherever you feel like stopping at. Now, if I stop anywhere, you say, well, that's not fair. You're supposed to go infinitely far, all the way out. You're stopping. That's true. Now, if you have an alternating series, we already have our alternating series estimation theorem, which says if you stop anywhere, error is no more than the next term in absolute value. Something similar is going on here. Okay. So this works alternating or not alternating. This is the Melvin-Hom version. It's not really my version. It's equivalent to what was before, but it just makes the formula look nicer. Okay. So if I stop anywhere, the error is no more, less than or equal to this weird thing. Okay, so I'm putting f n plus 1 of x in absolute value of x minus a to the n plus 1 over n plus 1 factorial. Okay, so if we were meeting face to face and I made you memorize this, it's the next dE over f. Okay, so if I stop after n, see, I'm supposed to go infinitely far. Like the sine function, I'm supposed to go infinitely far. Suppose I stop at the 7 factorial. See, that's cheating. You're supposed to go infinitely far. Okay. Yes, so what's the error? Error is no more than the next term in absolute value. Fn plus 1 of x, x minus a to the n plus 1 over n plus 1 factorial. Okay, so here's the way it works. Okay, you're going to get an expression here. You try to maximize this quantity. And right now, none of this makes sense. It's kind of nebulous, but I'll show you one example. And then you try to maximize this quantity. That should be absolute value also. Okay, you don't have to say maximize this quantity. This is already set. The factorials are set. They're not going to be any bigger or smaller. Okay, but since this has an x, this has an x, it's a variable expression. So you try to maximize this. Separately, you try to maximize this. And no need to say maximize this because it's already set. Okay, and these will all be on closed intervals. So if you look at the homework, starting with 13, x is between 0.7 and 1.3, way at the bottom. I can't show it to you because I don't have any more hands. But they give you an interval. Okay, 0.8 to 1.2, 0 to pi over 3, 0 to 0.1 or whatever. They give you some interval. Okay. So what's the maximum error that I have if I stop somewhere? If I stop after 3 or 4 or 2 or 5 or whatnot. Okay, so that's what we're trying to get. Okay, so I'm going to give you 13 star. Okay, and I'm noticing this is not in text. Is it close to something in the text? Maybe changed up on me. Okay, sorry. So this one's not in the text, but the next one I do maybe tomorrow or Monday, it will be from the text. So just give you an idea of how one of them works. 13 star. F of x is square root of x, centered at a equals 4, n equals 2, and we're between 4 and 4.2. N equals 2, that means it's a quadratic. What is the best quadratic approximation to the square root function? Okay, so a little mini timeout. Square root function looks like this. You're between 4 and 4.2. Okay. Now in Calc 1, you said find equation to the tangent line, right? So you know the tangent line. Now we're asking n equals 2, that's a quadratic parabola. What's the best parabolic approximation? So what I have in green there is looks like what it might be the best parabolic approximation. And you can go higher up. The higher up you go, the better the accuracy. the best cubic approximation, 4th degree, 5th degree, 6th degree, 7th, you can go as high as you feel like. Okay, so what's the best quadratic? If I were to replace this function, square root, I don't like the square root. If I were to replace it with a quadratic, a parabola, what's the best parabolic approximation? Okay, so n equals 2 means I take 2 derivatives, but for these problems, you actually need a 3rd derivative from here, because absolute value of Rn of x is less than or equal to the next derivative exponent factorial. So they tell me for T2, so if I just want a T2, the best parabolic approximation, I just need the 2nd derivative. But if you want an estimate of the error, you need to go to the 3rd derivative. So I will have to go to the 3rd derivative. Okay, so this is radical x, which is the same as x to the half. F prime 1/2 x to negative a half, 1/2 radical x. Double prime, negative 1/4 x to negative 3/2, or negative 1/4 x to the 3/2. And yes, I need the 3rd derivative. Okay, so I separate that. This stuff here is what I need to get my polynomial, my T2, my quadratic, but I need this. I drew the line to separate it. Okay. I need this to find the maximum possible error. Okay, so this part again is already set in stone. Centered at a equals 4. So it's going to be x minus 4 to the 0 over 0 factorial. Yes, that's 1. Yes, that's 1. X minus 4 to the 1 over 1 factorial. X minus 4 squared over 2 factorial. That's already set. And since I'm finding an actual polynomial, don't need the plus dot, dot, dot. I do need these extra coefficients. So the e exponent and the f factorial are predetermined. What's not determined are the d's, the derivative part. Okay, so I plug in 4 everywhere. F of 4, f prime of 4, f double prime of 4. So plug in 4, square root of 4 is 2. Plug in 4 here. 1/2 radical 2, 1/4. Okay, here, plug in 4. 4 to the 3/2 power means square root of 4, which is 2. 2 cubed is 8. 4 times 8 is 32, so negative 1/32. This 2 goes here. 1/4 goes here. Negative 1/32 goes here. Clean it up. So that's 2. This is 1. Anything near the 0 is 1. That's 1. So 2 plus 1/4 x minus 4 minus 32 slides down with the 2. So negative 1/64 x minus 4 squared. Okay. So if I had to replace the original function, squared function, with a 2nd degree polynomial, a quadratic parabola, I would use this. Okay, it's the best parabolic approximation. It looks like the x squared is negative, so it's curving concave down. It does look like it'd be concave down. All right, so that was just like problems 1 through 9. Now the new part. You say, well, that's cheating. You're replacing this with a quadratic. That's not fair. There's going to be some error. Correct. There's going to be some error. We're now going to estimate if I'm between 4 and 4.2, what's the maximum possible error that I could have. Okay, so that's the new part. So that's where this comes into play. So absolute value of R2 of x. Okay, what does this notation mean? The remainder, if I stop at T2. So it's T2 plus R2, T3 plus R3, T4 plus R4. See, we're supposed to go infinitely far, right? By cheating and stopping after T2, well, there's going to be a remainder. We call that R2, which means, okay, to work it out, the theorem says go to the 3rd derivative exponent factorial. All right, so here we go. 3rd derivative exponent factorial. So the 3rd derivative in absolute value, 3/8 to the 5/2, right? Absolute value of x minus 4 cubed divided by 3 factorial. All right, so see if you can follow this logic. I'm between 4 and 4.2. I'm trying to maximize this quantity between 4 and 4.2. Separately, maximize this quantity between 4 and 4.2. Okay, they don't have to be the same number. Okay, and you don't have to say maximize this. It's already set. Okay, so one more time. This part's just like problems 1 through 9. Find a polynomial. Now we're addressing that's not fair, right? You dropped off infinitely many terms. Yes, the theorem says we can get a bound for the amount of error. So how can I maximize the error? I do this thing. So I go to the next derivative exponent factorial. Third derivative exponent factorial. Okay, so for a problem like, I don't know, 19, you say n equals 3. I would have to go to the fourth derivative exponent factorial. For 22, I work out up to n equals 5, and then I go to the sixth derivative exponent factorial. You go to the next one, so to speak. Okay. 3 over 8 x to the 5 halves. How do I maximize that? Okay, the x is in the denominator. So we call by the reciprocal rule. By the reciprocal rule, this is the biggest when I pick the smallest number, right? I'm allowed to pick a number between 4 and 4.2. Since the x is in the denominator, by the reciprocal rule, this is biggest when this number here is the smallest. So I plug in 4. Right? Remember the reciprocal rule, right? Okay. To make an expression, this expression where x is in the denominator, the biggest is to pick the smallest value from 4 to 4.2. That's 4. Now, separately, x minus 4 cubed. How do I maximize here? Well, let's pick 4.2, right? I mean, if I plug in 4, that's 0. If I plug in 4.1, that's 0.1. The biggest is the furthest away from 4, which is 4.2. Notice you don't pick the same number necessarily. Sometimes it is. In fact, quite often it is the same number, but it's two different problems. Okay, what number between 4 and 4.2 makes this the biggest? And then separately, what number between 4 and 4.2 makes this the biggest? Then it's just calculating. Okay, this comes out to be what, 3 over 256, I guess. And that's 0.2 cubed divided by 6. And that's roughly 2 times 10 to the negative 5, or 0.00002. Okay, so that's my answer. 0.00002 in this particular case. All right, so let me summarize what's happening back here. Okay, so instead of using the square root function, I'm changing it to a quadratic. We're cheating. So that's not fair. Correct, there's going to be some error. The error is less than 0.00002. That's what we're trying to say. Okay. As long as I pick a number between 4 and 4.2. That's how the theorem works. Okay, so I want to show you that one problem. I know it's kind of a stickler. Okay. Problem 15. I'll do that one in its entirety maybe tomorrow. I was going to stop shortly, but I have time. We're down to just one last topic, folks. How to do 15 to 21. We have until next Wednesday to do that. Okay, so I was going to maybe do one more tomorrow, then I still have next Monday and Tuesday for that and review questions. But I want to show you at least how one of these works, so it's somewhat fresh in your mind a little bit. Okay, so tomorrow I was going to do in its entirety 15, not a star problem, but an actual problem. And I'll give you a quiz tomorrow. So tomorrow I was going to let you spend most of the time on the quiz. I'll give you the quiz. I'll do one more of these problems and then I'll quit. I still have Monday and Tuesday to finish up 11.11 and a review for the test also after that. Okay, but for now I'm done. Let me stop the share and see if there's any other comments in the chat. So anybody else have a question, please? Otherwise we're done for the day. Okay, tomorrow's quiz will be on 11/11. It will, well, not the latest part. So maybe just the part from 1 through 9, which is pretty much the same as what we've been doing. You just don't put the dot, dot, dot. So not on problems 13 to 21. Yeah. Potentially. Okay. All right, any other questions, please? All right, have a good day. We'll see everybody next time. Okay. All right, bye, everyone.
Thank you.
Thank you.